This episode of the HVAC School podcast is made possible by our sponsors. First off, this episode's sponsor, Refrigeration Technologies at refrigetech.com, founded by John Pastorello and now run by him and his son Mike. Really great guys, actually. Had a chance to meet them a couple times, and just great human beings. They run a great company, and they make great cleaners as well as other products. The Viper cleaners, if you haven't tried them, you need to. The aerosol spray can with the Viper cleaner in it is a really great all-around cleaner. It's got a nice pin spray to it, so you can use it on coil clean in place. A lot of different applications that we find for that, as well as the pan and drain spray. Nice replacement for pan tabs. You can find out all of these products, find them all, by going to refrigetech.com or by going to truetechtools.com. A lot of the products I talk about you can find at TrueTech Tools. Use the offer code GETSchooled for a great discount. A little secret, you may be able to find solder weld products at TrueTech Tools very soon, so keep clicking refresh on that. Also, Aeroasis, aeroasis.com/go. They make the nano and the bipolar air purifiers. You can use those very easily in your business, integrate those as part of your business strategy for IAQ. A lot of customers out there looking for solutions for some of their indoor air quality, allergy, odor challenges, and the nano as well as the bipolar are two products that we found that work great. They have these really neat Petri dish kits that you can use. You can get those from Aeroasis that you can set out and actually see before and after what's in the air. That's something I really like with Aeroasis. So find out more by going to aeroasis.com/go, fill out the form, and you can get information of how you can start using Aeroasis in your business. And then finally, NAVAC, navacglobal.com is where you can find out more about their products. We've talked a lot about the NRP 8DI and 6DI vacuum pumps with the built-in micron gauge, a really interesting pump that works great. I've bought a lot of them for my business and really enjoying those, as well as the NEF6LI flaring tool, the battery-powered flaring tool that just spits out perfect flares every time. If you make it a lot of flares, you work with ductless or VRF, then I would definitely say to check out the NEF6LI. It's the easiest to use flaring tool that I've ever used, and it really makes perfect flares every time in my experience. So check those out by going to navacglobal.com, and also you can find those at truetechtools.com.
And now the man who uses "they don't make them like they used to" as a universal verb, Bryan Orr.
This is the HVAC School podcast. Hey, what's up with Randy Travis? You know what I'm saying? I used to listen to Randy Travis back in the day. If you want an interesting Wikipedia article of what's gone on with somebody who's fallen from grace, my goodness, look at Randy Travis. What am I talking about? Okay, oh yeah, that's right. Let's focus. I literally was just thinking randomly about Randy Travis, and I figured I'd just say it while I was in front of the mic. Anyway, this is the HVAC School podcast, the podcast that helps you remember some things that you might have forgotten along the way, as well as helps you remember some things you forgot to know in the first place. And this week we're talking about additives to your system. And additives, somewhat like Randy Travis, have fallen on hard times. We found out a lot of things about additives where they can cause trouble. And maybe you're not somebody who's sold on it. I'll be honest with you. I've talked to a lot of people who have said, that I respect, who have said that it's oil and refrigerant only. And then I've talked to some other really smart people who use some additives now and again, and I've been torn throughout my career. I've kind of gone back and forth because, again, I'm not a chemist, so I figured, hey, let's bring on a chemist. John Pastorello with Refrigeration Technologies is going to talk about additives, and he really doesn't have a horse in the race because they don't sell any additives, so he just gives his honest opinion about them, the research he's done, what he's read, and I think you'll find it interesting. So here we go. John Pastorello with Refrigeration Technologies talking about refrigeration system additives. Thanks for coming on, John.
Thanks for having me again, Bryan.
Yeah, it's a pleasure to have you on. And I want to just start right off the bat and say that I don't think there's probably anybody who's better qualified to talk about this subject than John, who's in the industry, because John is a chemist and he does own a company that deals in chemicals, but the products that we're going to talk about today are not products that Refrigeration Technologies sells. And I think there's probably a pretty good reason for that we're going to get into. Nobody in this industry is completely unbiased. It's very difficult to find anybody who's completely unbiased, but I talked to John in the past about this. I'm still on the fence on some of these things, honestly, but John speaks passionately about it and obviously from an educated standpoint. So I just want to put that out there first. I'm going into this knowing that this is going to be a little bit of a controversial conversation, and I'm okay with that because I think these are the sorts of conversations we've got to have in the industry. So the topic on the table today is additives, and we're going to start with talking generally about acid inhibiting additives. So to tee this up, a lot of companies, us included in certain circumstances, will use acid inhibitors in cases where there is known acid inside of a system, meaning we have a burnout condition where we have stinky, nasty black oil, or an acid test kit is telling us that we definitely have acid in a system. And it's an older system, particularly with us. That's the only time we're going to do it, is if it's an older system where the life cycle isn't very long anyway. What are your thoughts on that?
First of all, for all our listeners out there, you don't have to know any chemistry here. I'm going to keep everything very simple. You don't need to know anything about any chemical materials. I'm going to keep it very simple. You don't have to take notes, and just use common sense. Realize that a lot of this stuff is sold through what I call creative marketing, or another word for it is total BS. Just listening to a commercial today where a drug company is touting a new cure for an illness, and they'll tell you all about the drug, what it cures. And then at the end of the commercial, it says, well, here's all the different ways that it'll also kill you. We're all familiar with those commercials. And with creative marketing, they'll tell you about all the problems that it cures, but they forget to tell you how it's going to kill your system in the end. So keep that in mind whenever you read some marketing material on some additive, some wonder cure, that they only give you half the story.
So you make a good point. I'm torn on this because it's like every company, every product, everything out there has two sides to it. If I think about, just think about the two sides of Bryan Orr. Like if you did a highlight reel of my life, I'd look like a superhero. But if you took all of my lowest moments, I would look like a total villain. So I guess we all have these elements of our businesses or our products that are good or bad or could be misused or could cause problems and all that. And of course, marketing by its very nature, nobody's going to highlight the negative side of their products. But my sense is that you feel like this additive market is an especially insidious application of this kind of concept.
Definitely. Where all these additives really originate are from the automotive side, on the DIY. And they're the easiest group to cultivate. Walk in your auto parts store and you got an air conditioning problem, and they might have a can of something you put in and it's going to cure. It was all right as long as they stayed on the automotive side, but now they have gone full-fledged into our industry, the commercial side. But you got to understand where all this stuff really originated. And what you don't know is that the reason they're here on the commercial side is because they got kicked out of the automotive side. So they had to find a new market.
All right, so let's start with something very specific. So we've got acid in a system. I use one of these little acid test kits, which I know you have some thoughts on that as well, which is kind of a different topic. But so I say, all right, I've got acid in my system. So what's wrong with me pulling something off the shelf that's an acid neutralizer? So let's first talk about acid neutralizers. Well, what could possibly be wrong with that, right? I want to neutralize the acid in the system.
First thing you need to know is that when you combine refrigerant and oil, it actually has a slight acidity to it. And let's say take a pH scale where 7 is neutral and the alkaline extreme is 14 and the acid extreme is 1. Your circulating fluids, refrigerant and oil, are going to have a slightly acid signature. They're going to be around the pH of anywhere from 5.5 to 6.5. Now, that is where the fluids are most stable. And all the metals and all the materials internally on your system are very happy at that pH. And all the oil additives that are used are designed to work best in a slightly acidic environment. So when you add some of these concoctions out there into your system, you end up flipping the pH of your circulating fluids. And what that does is for every action, there is an opposite and equal reaction. So you're going to cause, number one, the oil additives to possibly fall out or lose their function, such as a corrosion inhibitor or a viscosity stabilizer. So the system is no longer happy and the metals are no longer happy. And your windings, the insulation can become brittle and you can get gray masses of aluminum depositing in your oil. So for the sake of simplicity, you need to keep that system slightly acidic and not resort to using anything that's going to flip the pH.
First thing that I want to anchor down is that when you're saying it can affect the additives that are in the oil, what you're saying is the factory additives that are constituent parts of the oil that's in that Copeland compressor or whatever it is that it's designed to be in it, that when you change the pH of the environment to either neutral or potentially slightly alkaline, that can negatively impact some of those factory additives.
Exactly. You can just disable them altogether or just cause a reaction to where you have sludge-type particles forming in the oil.
Okay, but there is a recognition, because the old saying used to be, it's nothing but refrigerant and oil. That's all we're supposed to have in the system. But we are recognizing that there is some things that the manufacturers add to that oil that is not just oil, right?
Correct. Well, the people that prepare the oil for your OEMs or your compressor manufacturers, they design additive systems or additive packages so they will be compatible with all the metals and that they will protect all the metals. And all these additives are stable. That means they don't break down and cause any problems such as restrictions and other chemical reaction byproducts that can be harmful to the compressor. So all these additives are thoroughly tested. They go through compressor life testing, and that's how it's all designed to work.
So we talked about the acid neutralizer. So an acid neutralizer is changing the pH of the oil. That's what it's doing, is it's taking it from acid to neutral or slightly alkaline pH. And we talked about this whole idea of pH, alkaline versus acidic in coil cleaners. And I guess the thing that we all have to get into our heads is that there's a certain pH that it should be, and anything other than the should be isn't good. It's not like you can just make things more alkaline and then that makes everything happy and copacetic.
Right.
If you make it more alkaline, then that also causes problems then.
Yeah, flipping the pH is not a good idea in any type of chemical system. If I had a hydraulic brake system, that hydraulic brake fluid's a little acidic, and that's why you don't see any additives for brake fluid, because that can really mess someone up if they lose their brakes or eat the O-rings out of the cylinders or whatever. So you'll see in critical systems, no additives are ever used.
Now let's talk a little bit about another product, because then some people will say, okay, well, we don't use a neutralizer because we get that that's a problem. So instead, we use a scavenger. That's a term that's out there, an acid scavenger. So is that okay then?
Well, those are usually alcohols or alcohol solvent combinations. And alcohols have been proven to be detrimental to a system. Alcohols and solvents, they can cause your windings to become very brittle. And of course, we know what's going to happen after that. And alcohol also tends to attack aluminum, and the solvents also attack aluminum. And you end up with these gray masses of aluminum, actually aluminum particles in your oil. So that's why I would advise against that. Also, alcohols tend to be very hygroscopic. And we all know what hygroscopic means. It means it readily absorbs moisture from the atmosphere. And if that product is packaged in a plastic bottle, not metal or glass, it's been absorbing moisture. And the acid formation you think that you're eliminating is actually you're contributing more moisture to form more acid.
A lot of the manufacturers talk about the idea that they convert acids to salts that then are caught in the line dryer. That's a common thing that they say. And again, I'm in this position where I'm not a chemist. I don't have a deep understanding of these things. And you'll bring it up, well, because some people will say, well, these salts are a problem. And then others who sell these products will say, no, the salts are okay because they're designed that way to get caught in the filter dryer. What are your thoughts on that?
Well, like I said in the beginning, with every action, there's a reaction. And it's often you cure one problem and you just substitute it for another future problem. And I would say that it's that future problem you want to avoid.
You're not only a chemist, but you also have worked as a contractor. You had your own contracting company. You've worked as a technician. So you kind of know both sides of this. And I'm sure you've dealt with burned out compressors before that have the nasty black oil, and the customer wants a new compressor and the thing's 8 years old. And so you go out and you replace that compressor. What do you suggest doing in those circumstances to try to deal with the fact that you're going to have a more acid environment than what it was originally designed for?
The best cure there is and always has been is simply using a suction line dryer and a liquid line dryer. With the dryer, you're not causing any reactions. That molecular sieve is going to capture and hold any moisture, and there's going to be an aluminum oxide chemical in that dryer that's going to absorb and hold the acid. So there's no reaction. Still, the best cure out there for any burnout or to prevent any future burnout due to moisture or any type of air contamination you might get in the system.
So line filter dryer only.
Yeah, probably the dryer is a lot cheaper than some of those concoctions out there. So, I mean, there's sort of going to be a little bit more labor involved, but, these podcasts are all about, hey, what's the right way? What's the proper way for treating a burnout? And it's very simple, and it's very old, and it's time tested and true that the dryer is the simplest and easiest way to eliminate acid and moisture.
So our standard protocol, because a lot of people ask this and they don't believe that we actually do this, but we really do, is whenever we have a known acid situation, not only do we replace the liquid line dryer, any factory liquid line dryers, replace those with a new liquid line dryer, and then we add a suction line dryer at a location, depending if it's a heat pump or not. Obviously, we have to choose the location appropriately. And then we go back several weeks later and remove that suction line dryer and then either put another one in if it's still an acid environment that we can prove, or we remove it and straight pipe it back, which is obviously very labor intensive and is difficult to be competitive when you have to do all that. And I think that's the reason why a lot of companies would rather have something in a bottle that they can dump in and then forget it, and they don't have to make that return trip.
Sounds plausible to me, except for the fact I know what the chemical makeup of these concoctions are, and I say they're some of the worst chemicals you could ever introduce into a system. And it's not just my opinion. Most of the knowledge I have of system chemistry, I learned from a book called Fluorocarbon Refrigerant Handbook. And you can source everything I'm saying from that book. I mean, it's based on all the prior ASHRAE research papers and contributing articles from OEMs and compressor manufacturers that have thoroughly tested all this stuff and come up with the best solution. And it still boils down to filter dryers.
Works for me, like I said, because it's what we already do. Now, one thing that you and I talked about at great length is this idea of testing, though, because you still have this challenge of, even if you do use filter dryers, kind of step one is a lot of guys will go and put in a suction dryer and then leave it in for all eternity. And there's pretty much no compressor manufacturer who's going to say that that's how you should handle that. I mean, at the very minimum, you should be going back and testing to make sure that it's not restricted after you install it. And then most tell you that you should be removing it to get those contaminants out of the system when you had a known burnout situation. But how do you suggest going through testing? Because we talked a little bit about some of the popular tests that are out there on the marketplace and some of their limitations.
When you're testing for acid in a system, in a working system, what you want to test is the oil. You don't want to test the refrigerant. The refrigerant stays very, very clean. It doesn't absorb much moisture. It's all the contaminants are going to be in your oil phase. And so people that have these vapor testing kits or devices, they're kind of useless because 90% of all your contaminants are going to be in the oil. So what you want to do is you want to sample the oil for contaminants, not the refrigerant. And the oil will tell the full, complete story. And in fact, if you want to get really, really technical, I mean, you're working on some really critical refrigeration, you want to take an oil sample and actually have it analyzed by a lab to tell you exactly what's going on. As far as removing the suction line dryer, I don't think that's really necessary because I always, on burnouts, used both the suction and liquid line dryer, and I left the suction line dryer always in there. And when I bought condensing units, like Copeland condensing units, they would already come with a suction line dryer piped in and a liquid line dryer and sight glass. They'd be already piped into the condensing unit and straight from Copeland or Kramer or Heatcraft, wherever you're buying your condensing units from. That was back when I was practicing refrigeration. I don't know if they still do it, and I know they're always trying to cut costs, but they always came with that extra added protection of a suction line dryer. And I kind of like that because it's going to really prevent any particles, if not moisture and acid, from entering your compressor. I'm a big fan of always just leaving and using a suction line dryer.
Yeah, that's an area where most air conditioning manufacturers, I think this is sort of a division between refrigeration and air conditioning, because there are, example, we work in grocery store refrigeration. Well, in those applications, you're leaving suction line dryers in all the time. That's just a part of what you do. You leave them in and you change the cores if you have a pressure drop. But in air conditioning, most of the manufacturers are going to tell you that they don't want you leaving a suction line dryer in there. And the reason is because the circumstances under which a suction line dryer would be installed are contaminated circumstances. And so what tends to happen is a technician will go out, put in a suction line dryer after a burnout, and then they just never check it again. And once you start to get any significant pressure drop across that suction line dryer, that can impact your refrigerant density, which can then impact the cooling of your compressor, which can then burn out the compressor. So that's the challenge there. You're right in that if we were putting in suction line dryers and then regularly checking the pressure drop across them, or if we were putting them in when they were brand new and there was no real concern that you would have significant contamination, solid contamination that would block the dryer, then you'd be fine. But the challenge comes down to the fact that all these dryers have some screens in them, and those tend to get blocked when you have severe burnouts that then can pretty quickly damage a new compressor. And that's the challenge there. But I agree with you. In refrigeration, it's just pretty much a good standard practice. And in those cases, just leave it in, but then just check your pressure drop regularly.
Back when I started in the early 70s, 80s, the difference between an air conditioning mechanic and a refrigeration mechanic, the refrigeration mechanic actually owned and used a vacuum pump. The air conditioning mechanic would just blow the system through with R22 and just there. It's clean and dry. Start her up.
All right.
But I've left so many suction line dryers on air conditioning systems. I've never had any problems with them. In 17 years of doing air conditioning work, maybe replaced one or two suction line dryers where I had a pressure drop. But for the most part, I've never seen pressure drops across suction line dryers, even after the nastiest burnouts. You got to realize that when you have a burnout, most of that carbon residue is in the first 10 feet of your suction line. And if you make a habit of replacing a significant amount of suction line before you connect it to your compressor, you eliminate a lot of that carbon sludge. Maybe it's all in a matter of technique.
I think a lot of it is, yeah. And when you add in the fact that a lot of technicians aren't flowing nitrogen while they braze, and that can also contribute to some of the carbon buildup, that may be a lot of it. And a lot of this stuff, you can test it in labs, and that is valid. But when it comes to field practice, sometimes we do things that are not enough. And then sometimes we do things that are overkill because we don't really know where the lines are drawn. I can tell you, early in my career, before I had my own company, and even the first several years of my own company, I left suction dryers in all the time. That was the standard practice. That was what everybody did. And then you had some bulletins that were coming out and some best practices that were being preached about needing to return and remove them. That's what we're doing right now. But that could very easily change as you learn about products and you learn about what actually matters. I mean, a perfect example would be when POE first came out, everybody said you can have no mineral oil in with your POE. I mean, it is a disaster. It's going to turn into an atomic bomb. And then later on, nowadays, a lot of people are saying a little bit of mineral oil isn't really a big problem. A lot of the manufacturers are saying that. So
we are evolving.
Yeah, things you learn as you go.
Yeah. I can see the temptation for using an additive after a burnout because you just want to make sure you're not coming back to that system again. But I think that's where it gains all its appeal. It's that extra added peace of mind or insurance. But you read some of the Copeland research stuff and some of the recommendations, and they'll tell you right out. And you could look up some of the Copeland service manuals and procedures. They'll tell you straight up, there's no system that hasn't adequately been cleaned after a burnout by just using a suction line dryer and a liquid line dryer. It's in there. Just filter through their service manuals and you'll see it. And I believe that the reason they put that in there is there's so many different concoctions out of there that they don't want to have any warranty issues.
So I'm trying to think of what an alternative procedure would be that's a good process, because you bring up the question about testing oil. And the problem with that is that it's challenging to do, especially in air conditioning, especially in small stuff. It's tough to test oil. So after you have a running system, it's easy to test once you pull the compressor out. So that would be fairly easy. You pull the old compressor out, you test the oil. Okay, it has acid. So now I know I need to put in a suction dryer. Or would you say, if it's a bad compressor, just put in a suction dryer, and then maybe instead of going back and replacing the suction dryer, maybe just go back and do a pressure drop test 2 weeks later and just make sure you don't have any pressure drop? Do you think that might be an adequate replacement, or would you suggest retesting the oil? Because at that point, I don't really know how you would do that.
I'll give a little product plug here. We have a Checkmate acid and moisture test kit, and one of our tubes is exclusively for testing the oil. And you just milk a few drops off the suction line, and the indicator on there will turn any one of 6 different colors that will tell you the degree to which your oil is contaminated. And your oil will always have slight amount of contamination, and in the form of small amounts of moisture, small amounts of acidic compounds, because naturally the fluids are slightly acidic. And we have a test kit that kind of helps resolve or offers a little field test kit that can help you in deciding whether you need to change those dryers or not after a burnout, or to prevent a burnout, a future burnout.
Interesting. Okay, so I'm doing this on the fly, but this is how I do a lot of things. This is how I make a lot of decisions in life too, is just sort of thinking through it and then coming up to a conclusion. So I guess a way you could do it would be, all right, you've got a failed compressor. You pull the compressor out, test the oil. Oil is not acidic. Okay. At that point, if the oil is not acidic, would you still suggest putting in a suction line dryer? Or, I mean, this is your opinion, obviously, but would you put in a suction line dryer, or would you not put it in if you didn't test anything odd with it at all?
From my experience, every time I used a suction line dryer, I would never have a repeat compressor failure. So I didn't care whether it was a locked compressor or a bad internal equalizer valve or bad valves. I would, as a standard practice, always put in a suction line dryer. And that was my way of giving adequate assurance that I knew when I left that job that I probably wouldn't be back here to do another compressor job. And it's just from my service experience. That's what I learned.
That is a way that I have done it in the past. Again, you just hear so many different things. You talk to people you trust and they tell you something, and then you do it for a while until you get new information. So an interesting way to do that then would be just make it standard practice, do a suction dryer, and then maybe go back after a couple weeks as just a follow-up call. Like you said, take a couple drops off your suction line into Checkmate, test your acid levels, test your pressure drop. If you don't have pressure drop and you got no acid, then just leave it be. If you do have pressure drop and you are seeing some increased acid content potentially, or either or, then you would go ahead and replace the suction dryer at that point, but not worry so much about then removing it.
I'd replace both dryers at that point.
Both of them, right.
Oh, yeah, definitely. In all my service experience, I have maybe less than a handful of units that ever needed that second change out of dryers, just based on my experience.
I'm going to take a quick pause here, and I want to mention a little bit more about what I was talking about earlier, AirOasis and the Nano and Bipolar, and how you can use their Petri dish kits as part of your process if a customer is interested in indoor air quality products. As you know, I'm not a pushy sales guy. I don't really push indoor air quality as part of our sales process, but it is a good thing to add in to let your customers know when you're on a service call that you do have some options, that you can do some assessments on their home. I definitely recommend using indoor air quality products like the Nano and the Bipolar as part of a more whole home assessment, where you're looking through the attic, you're checking insulation, you're checking for proper boot sealing, checking to make sure that ventilation is venting properly out of the attic or crawl space, those sorts of things. I don't like to just throw products at it, but the Nano and the Bipolar are great products that you can offer, and they do work. And one way to prove that they work is you can use a Petri dish. You fill it with this product, is like a gel. It's called an agar. You add that into the dish, you leave it out for about 5 minutes, just open to the air, you seal it up, and then for 5 days you incubate it and you see what grows. If the customer doesn't like what's growing in the air, then they can put in products like the Bipolar or the Nano, give it a while, and then do it again, and they can show the results. And it's really a neat thing that you can do that kind of shows the benefit of the product. And you can get those through Air Oasis. If you're interested in those, then I would encourage you to go to airoasis.com/go, fill out your information, tell them what you're interested in. Maybe you're interested in the Petri dishes. Maybe you're interested in trying it out for personal use, one of these products in your own home. They work with technicians and contractors all the time on that, and they're great people. They make these right in Amarillo, Texas. Salt of the earth human beings. That's airoasis.com/go. Let me ask you this real quick, because this came up a few years back. There was an issue with a compressor type brand, will remain unnamed. Manufacturer of the OEM comes back and says, hey, there was an issue with an acid inhibitor in this oil, and so now we're going to suggest that you use this part number. Part number goes back to something that's been used for years out there called Zerol Ice, is one trade name it was under. And they suggested that you use that to fix gummed up expansion valves. So expansion valves were being gummed up by what they claimed was a corrosion inhibiting additive that was put into the oil by the compressor manufacturer.
Yes.
So this is one case where the OEM says to us, now use this additive that is an off-the-shelf additive that this company's been pitching for a long time, and that sort of brought some legitimacy to the idea of using that additive. In the first place, I hardly even know what this additive does. It did work in a lot of cases to free up expansion valves, but me included, most of us don't really understand what was going on there. Do you have any thoughts on that?
Oh, yeah. I've looked at that problem extensively. And the problem was that the company supplying the OEM spec oil either put too much corrosion inhibitor in, or they substituted the corrosion inhibitor for a foreign brand of the same type of corrosion inhibitor. In other words, corrosion inhibitors are very, very expensive, okay? They're probably the most expensive additive that is in the oil. And maybe to save cost, they went overseas and got some corrosion inhibitor, supposedly the same molecule, and bought it from India or China. And of course, the purity wasn't there. And it was the impurities in that corrosion inhibitor that they substituted that was causing the problems. And where all your problems are going to occur is at the lowest point, temperature point in the refrigeration system, which is going to be right at the exit of the expansion valve. That's where all your solid materials are going to precipitate out. And since it's a corrosion inhibitor, it's going to leave a residue. Now, as far as curing the problem, all you needed to do was add about 2 to 4 ounces of raw POE oil to the system to dilute it back, dilute the amount of corrosion inhibitors that they accidentally put in. And it's kind of like if you oversweetened your iced tea. Well, I would take raw iced tea, unsweetened iced tea, and pour it back in, so I take the sweetness out. Now, there wasn't anything on the shelf that was raw POE. The POE that you would buy in a can already had corrosion inhibitor packaged in there. So you weren't going to dilute it by adding any more POE oil. But there were like aftermarket additives that basically were nothing but mineral oil and foaming agent. And you can maybe get some success by diluting it back with that. So it was a matter of diluting back and getting your additives, your corrosion inhibitors back in balance. Maybe a lot of them didn't dilute back because the corrosion inhibitor had already precipitated out and became so hard that nothing was going to take it out other than a solvent. And I know that a lot of people resorted to using the Sepco 88, which is kerosene, and that's a good cleaning solvent. I think these compressor manufacturers, by telling you to buy this off-the-shelf product, we're just trying to buy some time and save some money on dishing out warranty repair tickets and replacing expansion valves at their cost. That's my take on it. And we looked at that, and it was kind of at first, usually when there's a factory problem, they'll blame the technician. It was probably your fault. You didn't evacuate it enough, or you did something, you didn't put a right dryer in there. They usually blame it on the technician. And it took them a while to come around and really fess up. And I think they prolonged the problem, and it got too immense. And they were thinking dollars and cents.
So you mentioned solvent products. There's a whole class of products that have hit the market that purport to help you return oil from the evaporator coil back to the compressor and improve evaporator performance. I mean, there is all these, and a lot of them almost kind of come across like multi-level marketing companies. We have a salesman in your area, and he's going to do a demonstration showing that your delta T increases or whatever. I've never given any of that stuff the time of day, because it just sounds so much like snake oil. But is there any truth to that? I mean, let's say you have an evaporator coil that's logged with mineral oil. It's got a lot of mineral oil that's gotten into that evaporator coil. Are there some products that are returning that? And is that solvents, or is that just some POE or something else, hydrocarbons that are returning that? What's going on there?
Okay. In that sense, yeah, you can get oil to return back to the compressor by using a solvent. But in the same light, all you're doing is you're reducing the viscosity of the oil so it'll flow better. And that's a pretty simple trick. A lot of these people out there with the additives, they'll have a solvent, and then they'll have a foaming agent along with compressor oil in their little miracle can. And the solvent, of course, thins the oil out. You lose viscosity. You can possibly have some lubrication issues down the line. But the most interesting ingredient is they put a foaming agent in there. And what that does is when you add this additive to your compressor, the foaming agent causes the oil in your compressor to foam. And it starts foaming up the sides of the walls of your compressor. And what that does is it makes your compressor run quieter. Of course, unknowingly, you think, well, wow, this compressor is running really smooth. And really, it's just a sleight of hand. It's just a magic trick that you're causing your oil to foam, and that's dampening the sound of your compressor. It's an old trick used back in automotive days when they had additives to where it would quiet noisy valves and lifters. And what it was just a foaming agent. And the foaming agent was right to the top where your valves are, and it would dampen the sound. You still had noisy valves and lifters. It's just that you couldn't hear them because of all the foam up there.
I imagine also that when you have a foaming agent, that potentially it's throwing some oil into places that maybe it wasn't going before, which could potentially temporarily reduce some noise just from the actual parts moving together. But again, when you're foaming it, you're also greatly decreasing its viscosity. So it's not going to necessarily do the job that it's intended to do. But I have this kind of cartoon going on in my head thinking about if you're foaming oil up, that you're probably getting it into some spots that it wasn't previously getting. Yes.
In fact, actually, there was a study done by a really smart guy at Tecumseh. Guy's name was Sander Verkorkian, or something like that. And he actually was doing experiments where he said that oil foaming could be beneficial under certain circumstances, under certain load conditions. And it got pretty technical. But in conclusion, he said that oil foaming was still not desirable, and that only under certain circumstances, certain load conditions, that it was beneficial. So there was a good side to it, but mostly a bad side to it, because all the viscosity of your oil gets trapped in the foam. Foam is much more stickier and denser because that's where all your viscosity goes.
I'm kind of thinking, all right, I guess if you had a low refrigerant velocity problem, like say you had a system that was running low load, dirty evaporator coils, airflow problems, which is a really common problem in our industry. And so now you have oil return problems. And so you've got an evaporator that's logged with mineral oil. And so you add something, an additive, something in a can that has a foaming agent, and then it has either a solvent or something else that's designed for oil return. I imagine that in the short term, that might actually show some results, because if you're stripping some of the oil out of that evaporator coil, that is going to increase your heat transfer. And then if you're helping it get back and then you're foaming it into that compressor, you potentially would have a short-term result of better heat transfer, quieter compressor, maybe even lower amperage. But in the long run, what you've done is you've diluted that oil, you've decreased its viscosity, and so it's not going to do the job that it was necessarily originally intended to do. It may do some other things that became kind of secondary results, but the core job that it's supposed to do in that compressor, it's probably not going to do as well as it should. I don't know that that's necessarily true, but that makes sense to me that that may be the reason why some people swear by some of the results. And it's like a lot of things. It's like washing a condenser coil and then testing it while it's wet and saying, look, washing your condenser coil just dropped your amperage by 5 amps. But then if you go back 15 minutes later, it's right back to where it was before. There's a lot of little tricks like that in the industry, and this sounds kind of like one of those sorts of tricks.
I think you've got it nailed. Are you sure you're not a chemist?
No.
I agree with that 100%.
Definitely not a chemist at all, but I do like to think about how machines work. And it bothers me to no end when they won't tell me what's in this stuff. That's been a challenge that I've had in the past as I've talked about different products and used different products. It just nobody will tell you what's in it. And so I can't do my own research, and that drives me insane. And I understand on one hand why they wouldn't, because of course, many of these chemicals are very inexpensive chemicals and they make wicked profit margins on them, selling them as a particular brand. I mean, that isn't to say that they don't work. They don't work probably for other reasons, but it's an interesting consideration. Let's move on to the final additive. I mean, we've gone through a lot of different additives here, but the final one, and probably one of the most popular, is the good old leak sealant. I mean, sometimes those will have a UV dye in them. So let's talk about those. What are your thoughts on that? I think I already know, but let's hear it.
Well, then again, we go back to the automotive sectors where all this stuff started. And in automotive, you got O-rings that shrink, and you got a shaft steel on the compressor that always leaks. It was a natural fit to have stop leaks in the automotive side until they started telling people that it wouldn't void the factory warranty, new car warranty. Well, when they started locking up compressors and those compressors got back to GM, Ford, Chrysler, they said, no way. Anybody who puts stop leak in a air conditioning system in our cars, we will void the warranty. And the only cure is to replace every component in the system. Compressor, lines, evaporator, everything needs to be replaced, because that's the only way you will rid the system of the stop leaks. Now, that's where it started. They basically got kicked out of the automotive industry. So then they came over to the HVAC side because they needed another market, and they got smart, and they did not put the claim on the cans or the bottles that wouldn't void compressor warranties. They came up with, well, you only use it as a last resort for something that's old and probably needs replaced anyway to get the people by for another season or two. And that's the strategy that has worked for them, and it's kept them out of trouble. Chemically wise, basically what these stop leaks are, you're introducing solid particles into the system. And the theory would be that these fine, powdery, solid particles would travel with the oil and become trapped in the leak site. Now, everyone thinks of a leak as a hole. Well, it's really not a hole unless you drilled a hole or punctured it with a nail. Usually a leak is a path. It is zigs and zags before it actually comes to a leak site. And the theory is that these particles get trapped inside there, and they have the consistency of a rock. They're very, very fine. Now, they'll tell you a story that is creative marketing, which we talked about earlier, which I call total BS, that, well, it's going to harden when it senses the air or moisture outside the leak. And with a little bit of reasoning and a little bit of experience, that doesn't happen in the real world. If you had a small leak, let's say you're soldering up a system and you have a little bit of pressure on the system that you didn't know about, you're soldering a joint, even with the smallest amount of pressure and heavy heat and heavy solder, that solder joint will never seal. There'll always be a little donut that forms because pressure wants to get out. And I'm sure everyone's done that where they've had a little bit of pressure on a system and they're trying to solder it up and that joint won't solder up. It keeps popping a little hole. Well, that's the reason why they can't work in theory at all, because even the slightest bit of pressure, it'll find its way out. There's no way moisture can get inside a leak is what I'm trying to say. You'll just always get a donut if there is moisture surrounding the leak. The refrigerant will escape, and if the leak sealer actually does harden with moisture, you'll still have the leak, that hole, but it'll form a donut around it. So that is how they work. Some of those leak sealers out there are placebos. I've tested all of them. And this goes back to the 80s when these leak sealers, stop leaks started coming out that supposedly moisture cure. And then there's others that claim that they're use a different science. And we found some of these leak sealers are just nothing but mineral oil or alkyl benzene. And hey, it either works or it doesn't work. And it surprises me. I'll go on like a Facebook or HVAC Talk, and they'll say, well, this particular brand really worked well for me. And we haven't had any problems with compressors locking up or expansion valves seizing. And I know what's in the product. I know the product is nothing more than mineral oil. So it tells me a lot about serviceman's expectations and wishful thinking on their part. We all want that cure, that magic in a bottle. We all want it to work.
Yeah, so this is the one of all of them. All the rest of them go by the wayside pretty easily for me because, again, for example, with acid, I mean, the idea is you want the system to work. With leak sealants, I was always a absolutely no leak sealant guy for most of my career. And then I was introduced to some products that were marketed as polymer free. I've tested some of the products that are the most aggressive on the market and mixed them with water and in the presence of oxygen, and you can see that they harden. And so I'm never going to put those in my gauges. I don't care if they work or not because it's going to damage something. And then I've tested other products. I know you've talked about this on other podcasts too, and I've listened to that. So I know your stance on all this.
Yeah.
But it's interesting. And I don't dispute it even, actually. But there are some cases. I did an actual before and after on a small formicary leak where I visually looked at bubbles on the system before and after. And there was a significant decrease in, it actually was still leaking slightly, but it was barely even discernible, whereas before I was getting visible bubbles using your product, Big Blue.
Good choice.
Okay, thank you. That to me told me, and this was an older system, and in fact, in this case, on that test that I did, it was a customer who requested a product by name. And I initially said, no, I don't really want to do that. And I said, you know what, this customer wants it. I'll use this as a test. And there was definitely a significant decrease in leak rates. Now, you thought about things like pressure and on-off time and all that. I tried to kind of test them in similar circumstances. Of course, it could just be completely that it was just a fluke. Who knows? But there's been several people who have shown, one of my friends, Cameron Conley, he's a big commercial ammonia chiller tech, owns a company down in Texas, and he used a particular product that's a non-polymer product, and he had been recharging his system every 6 months. He put it in, and now it's been over a year, and he hasn't had to recharge it. Those sorts of circumstantial evidences are what keep people using it. And I definitely fall in the category of somebody where I only use it if it's somebody who understands that it may not work. It's an older system and they're choosing it as a possible way to get through a season or two. So I still have that. I'm doing exactly the same thing that you talked about, which is sort of relying on that possible placebo effect to say it seems to work. So what would you say to somebody who's like me who says, I get what you're saying, John. I have no reason not to trust you. You have no dog in this fight. You've looked at it closer than I have, but it still seems like these things work in certain circumstances. Is there any possible validity to that?
Well, whenever you're circulating solids in your oil, there's a chance that some of those particles can trap inside a leak path. And I don't think they would necessarily stop the leak completely, They can slow down a leak. I've seen it. I've had it in the lab. I've tested all this stuff in the field. And I can see where we saw some slowing down of leaks. And the thing about polymer, non-polymer, none of them are polymers. Polymer was just a fancy word to use because no one understands what a polymer is. And so they throw the word polymer out there. And then so the next guy comes along and says, because there's been some problems with the polymer type, and said, well, we don't have polymers. Well, none of them have polymers. Just a little chemical nerdy thing I'll just throw in there. But it takes me back to the first leak sealer I ever saw, and that was really back in the 70s. And what it was mineral oil, and it was loaded with graphite. And the graphite doesn't dissolve in the oil. It's just black. And you're supposed to put this in your system, and the graphite would travel with the oil. And graphite's a lubricant, so it can't lock up anything, right? But the graphite would travel with the oil and would get trapped in the leak site. And the graphite came in different particle sizes. So they were big and small. They were all microscopic. Graphite is pencil lead, basically. So the problem with the graphite was that it's electrically conductive. So within about 3 to 6 months of this graphite pounding against your windings as it returned back to the compressor, you end up with a really, really nasty burnout. And the problem with that, because I ran into systems out there that had graphite leak sealers in there, the problem was, how do I get it out? Now my customer has lost a compressor. How do I get that stuff out? And you're faced with the same situation. How do you get that product out? There's nothing that'll cure it except replacing the entire system. Evaporator, line set, condensing unit, everything needs to be replaced. That's the whole problem. Now, once you've painted yourself in a corner, how do you get out? And that is something a technician needs to realize, especially if it's a system 8 to 10 years old, still maybe have 5 years left in it. It's going to be a perplexing problem for you. Always have that in the back of your mind, that once it's in, you can't get it out.
Kind of where we land on this is that good, solid, best practices are always the best place to be. And so that's things on the acid side. That's things like using liquid line and suction line dryers. It's on the leak side. It's about having a leak detector that actually works. And we've talked a lot about that. Guys, they have these electronic leak detectors and they don't even know how to confirm that they're working properly. And then it's doing your leak detection properly. And it's using bubbles when bubbles are appropriate. And it's using the proper strategies of how to fix leaks, repair leaks properly. I've been working a lot with Solder Weld lately, looking at some of their products for, repairing all different types of leaks, whether it's aluminum or aluminum to copper, all these different applications, and really trying to actually fix things rather than solutions in a bottle. That's what we should always be seeking out wherever there's any possibility to do so. And what I like about Refrigeration Technologies is that you have always looked for real solutions rather than being attracted to chemical solutions that are easy ways to make a buck, but may paint you in the corner in the long run, where now you're stuck and you've got something in the system that now you can't get rid of. And you have to use some creative salesmanship rather than good technicianmanship, which is what we talk about here. There's nothing wrong with sales. Sales isn't a crime, as long as it's honest and truthful and based on good, sound science as much as we possibly can. And in some cases, we're in positions where we do have to trust people. But as best possible, trust people who have proven themselves to be trustworthy. And I would consider John and Refrigeration Technologies to be a company like that. So thank you again, John, for taking the time to do this. And thank you for being what you have been to the industry, which at this point, hopefully this isn't offensive, but I would call you the elder statesman of the HVAC chemicals industry. So
you're a chemical nerd. I'd like to end this by saying that all those listening, the only chemistry you really need to know is that nothing belongs in the system other than the proper oil and refrigerant. That's it. That's all the chemistry you need to know in our industries. And if you follow those rules, you'll never get in a situation where it's going to zap you. I had an experience here several months ago where I was in a supply house and they said, John, can you help out this contractor? And I said, well, what's the problem? He says, well, he put leak sealer in a 25-ton system, operated a wing of a hospital. and he's not their normal service guy. They called him out on emergency repair. So the guy put leak sealer in and topped off the refrigerant, and maybe a month later, the compressor locked up, and it was a Linux system. So they called the Linux service people out, and they read the guy's invoice, and they told the hospital, and they said, this is not a Linux factory authorized repair. This guy that did a repair is responsible for replacing your whole system. And the guy was pinned. He's pinned with a lawsuit. And I don't know if anything's ever settled since then, but he was looking at replacing at his cost a 25-ton unit. Plus, they were nailing him for negligence on top of that. So I just have this saying, the leak stop people, they say, well, never use it on a new system, only use it on an old system. I say, never use it on a system you can't afford to replace. Then again, just follow the basic rules, basic refrigeration practices, and you'll be healthy and wealthy in this industry. Don't look for the shortcut.
I'll agree with healthy. I'm not always so sure about wealthy.
No. There's a get by in this industry. You can get by. You can get by and make a good living doing refrigeration and air conditioning. No doubt about it. But I was not one of those guys that could take it to the next level where you have 40 service trucks and doing $500,000 installs. Just couldn't take it there. And most of the people listening aren't there either. But gosh, you can make a sure good living off this industry. And it's been very, very good to me. I'm one of the lucky ones. But
absolutely. Well, thanks for taking the time to do it. And thanks for all you do. And I'm sure we'll have you on again sometime.
And thank you for all the good questions. So very insightful. And like I said, a lot of this information is found in a textbook, and generally my opinion, but mostly it's all in a textbook called Fluorocarbon Refrigerants Handbook. And it's been around a long time.
Nothing like old books. We've talked about that a lot here. You're on a long list of guys who have come on and found that a lot of this stuff has been known for a very long time. Dan Holohan talked about that. Jim Bergman talks about it all the time. Dick Wurz talked about it. A lot of really good educators and minds in the industry have gone back to. A lot of this stuff is the basics, stuff that we've known for a long time, and we start listening to marketing rather than principles. So good reminder for all of us.
Well, thank you, Brian. I hope we have more of these podcasts, and hope maybe we got some education out there in the field, and guys will think twice before doing what they think they need to do. Just fall back to what is the right way to do things. And I think most people listening to this podcast really just want to find out the right ways to do things.
Yep. If they're listening to this, hopefully that's the type of technician that they are. And generally we find that that's the case. Those are the types of techs that we interact with on Facebook and on the website and all that. And yep. So that's why I wanted to have you on. I know that there's going to be a lot of questions that come out of this. You can always get me. John is also in the HVAC School Facebook group. So if there's questions that come out of that, I'll kind of field some of those. And I'm sure we'll have a healthy conversation moving forward. But I appreciate it, John, and we will talk again soon.
Thank you again, Brian.
All right, thanks for listening to the podcast. I'm a big fan of Refrigeration Technologies. I'm a big fan of the Pastorellos. I think they're good for the air conditioning and refrigeration industry, which is sort of my litmus test. I turn down people who want to sponsor this podcast. I turn down people who want to come on the podcast a lot. I get a lot of requests. I let people on who I think are going to speak truth. They're going to say things that are good for the industry. Even if I don't necessarily agree with all of it, I agree with the heart behind it. And John is one of those guys where I think he honestly cares about the industry. He honestly cares about putting products out there that work. And I really believe that the reason why you don't see any additives from Refrigeration Technologies is that he doesn't believe that it's good for the systems. And so that's why they don't sell those types of products. They sell a lot of great products, Nylog, Big Blue, pan and drain spray, Viper cleaners, lots of great stuff, but nothing that's a traditional additive to go in the system. And I like that. I think good on them for following what they believe is what's best. And that's what we try to do here at HVAC School, and that's what I try to do in my business. And I'm sure if you're listening to this, that's what you try to do as well, even if you don't necessarily come down in the exact same place as John or I on certain subjects. So one thing that I wanted to mention is that we do have new apps out on the Android devices and iPhone in their respective stores. You can find them in Google Play Store or in the App Store. And some of you sometimes struggle with setting up an app to listen to the podcast. You can listen right there We make it nice and easy to the podcast there. You can also find the tech tips. You can search the tech tips and the podcast easy there. We found that a lot of the traditional podcast apps can be really tricky to search, and so we've made that easy by creating an app. But we also have some calculators on that app that you may find very useful. A voltage imbalance calculator for 3-phase, a nitrogen pressure change calculator. It shows you the change in nitrogen pressure at changes in temperature. And then finally, probably the most useful is the underload capacitor calculator, which just takes a couple steps out, makes it a little bit easier to calculate capacitors under load if that's something that you do day in and day out at your business. If you like to shut the system off and pull the leads off and test it that way, that's also okay by me. I'm not a purist when it comes to that. I think those are both good ways of testing, but we find that it's nice to be able to test them under load. You're testing a running system. You don't want to have to shut it down and pull the leads off, discharge the capacitor. It makes it very easy to do. And we have a calculator and the HVAC School app available for both Android and iPhones on the stores. Sometimes when you search HVAC School, you may have to scroll down a little bit because it's a new app. They don't necessarily show us first, but you will find us if you're looking for the HVAC School logo. I broke down the other day in my car, and I needed a little bit of help, and a guy pulls over, helps me out, and he's from Oklahoma. It turns out he was an okay guy. Thanks for listening to the podcast, and we will talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.